There is one very important topic in the geography of India, that is plate tectonic of India. There are several topics describing it. For example, the plate tectonics of Indian plate. It is also called Indian plate and it is also called Indo-Australian plate. Hence, this may be termed as plate tectonic of Indian plate, plate tectonics of Indo-Australian plate, or plate tectonics of Gondawana plate, because it is also called Gondawana plate on the basis of the tribe Gond found in Maharashtra and MP, and after the name of this Gond tribe, this plateau land of India is called Gondwana, and the structurally uniform regions of this Indian plateau, which are here Australia, Africa and South America, collectively called Gondwana land. And after the disintegration of Gondwana land, this Indian plateau reached here. Hence, it is called Gondwana plate. This plate is the only named after a country like Indian plate. Its one terminology is also Geo-Physics of the Indian plate. Here we have to first outline the Indian plate or Indo-Australian plate or Gondwana plate. For its demarcation of the boundary, we have to start from this point. Previously in geological past, this Indian plateau was physically attached with Madagascar, and Madagascar was physically attached with South Africa. Due to some endogenic forces, this India was separated from Africa. Slowly it moved here, forming a conservative plate margin along this Carlsberg Ridge. This Carlsberg Ridge is made up of volcanic lava deposit underwater, the depth of which is 1752 meters below the sea level. Thus, this Carlsberg Ridge is a type of mid-oceanic ridge which runs through the middle of this Arabian Sea. Now, it extends south, forming the southern boundary of Indian plate or Indo-Australian plate or Gondwana plate. Here in south, its extension is termed mid-Indian ridge. This is also submarine volcanic ridge, the depth of which is 2067 meters below the sea level. Its further southeastward extension is called Southeastern Indian Ridge. Indian Ocean extends up to this point, as we already have discussed that from along this Tasman Ridge, Indian Ocean, Southern Indian Ocean and Pacific Ocean are separated. Hence, it is called Southern Indian Ridge. It is also submarine, the depth of which is 3017 meters below the sea level. This ridge separates Antarctica continent from this Australia continent, and here it is South Australian basin, it is Walton basin. These are the low-lying areas of the ocean. Its eastward extension is here Kermadec Ridge. Kermadec Ridge separates this Australian plate, also called Indo-Australian plate, from this Pacific plate or West Pacific plate. Along this ridge, massive volcano erupted, forming New Zealand Island. Next, northward extension, it is here Norfolk Ridge, which separates this Australian or Indo-Australian plate from the West Pacific plate. It turns westward, where here Java, Sumatra Islands, which are of volcanic origin, are located. And to its east, it is West Pacific Plate, wherein Philippines minor plate is located. And here it is very intricate or complicated geophysical structure or process. Here it is Indochina, where Myanmar plate or Shan Plateau platform and plate is located, which is geological part of Angara land, or it is the part of Eurasian plate. But the eastern boundary of Indian plate, which we are studying at present, is demarcated by here Aracanyoma mountain, which has two branches, one moving towards southeast passing through Sumatra, Java and Borneo, the next along the 90 East Ridge, and 90 East Ridge generally is close to Underman and Nicobar Islands, which are located on this plate margin, and this plate margin has now become constructive. And here to the west of it, it is a geosyncline, one of the two major geosynclines on our planet Earth. This is the largest and most active geosyncline in Bay of Bengal, which is undergoing subduction due to the voluminous sediment brought and deposited by Ganga and Brahmaputra system. We are moving along the Aracanyoma, which is the destructive plate margin of Indian plate, and it turns westward from the Namcha Barua hills, and its westward extension is also destructive plate margin, on which are located the three mountain ranges of Himalayas. We move westward along this destructive Indian plate margin, reach up to Pamir Knot. From that point, moving southwestward, here again is destructive plate margin, where two ranges, Suleiman and Kirthar, are located. Now we have completed one journey of Indian plate, its margin, where submarine ridges are located, volcanic eruptions are taking place. Contrary to it, its eastern and northeastern and northern margins are destructive. In plate tectonic world, in the study of plate tectonic in its theoretical aspect, we have already studied that plates have two margins, and here it is clear that the west and south part is constructive, while east and north part is destructive. So this is about the plate margin of India and how geophysical processes operated here we have to study. To begin with its geological history, we have to look on the brief geological history of India or Indian plate. In the beginning, before 200 million years ago, there was a land which was called Pangaea. In Carboniferous period, that Pangaea, a composite land including Angara and Gondwana land, was disintegrated. You will remember that this was 200 million years back in Carboniferous period. The forces breaking that Pangaea in two parts, that is Angara land and Gondwana land, were two. Number one, the hot spot in mantle, and number two, Euler motion. Those continue working, and first those worked in north land, that is Angara land. Angara land before 180 million years ago was broken in two parts. Number 1, North America, and number 2, Europe. North America drifted westward, was separated from Europe, with the result the ocean opened between North America continent and Eurasia. That was called North Atlantic Ocean. Thus the opening of North Atlantic Ocean started. 120 million years back, the same two endogenic forces, endogenic geophysical or tectonic forces operated, with the result the southern Gondwana land was broken in several parts, and its western part, that is South America continent, started moving westward, was separated from Africa continent, with the result between South America and Africa lands a new ocean started opening, that was called Atlantic Ocean. Now UPSC may have question why first North Atlantic Ocean started and after that South Atlantic Ocean started. Its answer is very simple, because it is assumed by the geologists that this Pangea was on the South Pole. It was broken in two parts. First, Angara land drifted northward, reached on the equator and was affected by the endogenic forces, hot spots and Euler motion. Hence, it was disintegrated first and North Atlantic opened first, then South Atlantic. After that comes. Now next stage is 120 million years ago. This Indo-Australian plate started moving northward at the rate of 12 cm per year. Hence, Indian Ocean started opening. As we have already discussed that this India, not this India, rather this Indian plateau land was geological part of Madagascar and of South Africa, and it got separated from this Madagascar and South Africa due to endogenic forces which disintegrated the Americas from Eurasia and Africa. In the beginning, this Indian plateau started moving northward at the rate of 12 cm per year. 12 cm is a sufficient geological speed of a plate. When it started moving northward, there a fracture was developed and this widened, wherein the waters of Indian Ocean entered, with the result Arabian Sea started opening. Later on, it was named on the basis of Arabian Peninsula or countries, and this Carlsberg Ridge came into existence. Here, it is noteworthy that Carlsberg Ridge is still geologically active and volcano is erupting here, and the width of Arabian Sea is widening, its area is increasing. It is also noteworthy here that when Indian plate or India plateau land moved northward, it had two arms. Number one, this northward extension of Aravalli, and here the northeastward extension of Raj Mahal Hill. These are the Archean period Archean period mountains having very old rocks and structures. Take these two as horn of bull. When two bulls fight together, they never raise head, rather keep their head down so that their two horns are aggressive. If we take this plateau line as bull and it moved from south to north, its both horns were inclined, with the result in the north here there was Tethys geosyncline, which was filled with the sediment brought down by the rivers from Tibet Plateau in the north and from this Indian Plateau in the south. That sediment was exerted pressure from the south by the two horns, that is Aravalli, the western horn, and the Rajmahal eastern, resulting into the origin of this Himalayas. There may be question that there are three ranges in Himalayas: Greater, Middle, Shivalik, extending parallel from Pamirnath to Namcha Baroa. But here there is one Karakoram range, neither parallel nor so long as the three ranges of Himalayas, but very high, having K2 or Godwin, Austin, and this Karakoram range is called the shining crest of the Earth planet. Why? Why this is of short range? Its answer is tectonically very easy, because this western horn of the bull, that is Shivalik, entered first in the Tethys geosyncline, causing heavy pressure. Why heavy pressure? Because the rate of northward movement of Indian plate was very high, 12 cm per year. That's why Karakoram range originated and K2 came into existence. The same is the case with this eastern horn of the bull, that is Rajmahal Hill. Due to the northeastward pressure of Rajmahal Hill, here two very high peaks came into existence: Everest and Kanchenjunga. There may be a question by UPSC why these high ranges are here, which can be explained only by this tectonic process. And when this western horn collided near Dras, because here story continues that some 80 million years ago Indo-Australian plate collided with Tibetan plate at Dras. Dras is a place located in Jammu and Kashmir. Dras and Kargil were famous during Indo-Pak War, and Dras is a place near which the Indian plate or its northern horn, this Aravalli, collided with the Tibetan plate, and due to this collision the Karakoram originated. Hence, Deccan lava flow in Cretaceous period. This is the time of Cretaceous period. Why? Due to collision of the Aravalli with Tibetan plate, why lava in the Deccan region? It is another story, because when this plate collided, or the western horn Aravalli collided with Tibet, there was pressure, and this collision pressure was linear from north to south, and when this bull was inclined, its southern part was raised. Due to it, here there was a fracture. Due to its fracture, the land to the west of Western Ghat mountain was broken, and it got submerged. And due to its submergence, the water of Arabian Sea came over here. It is again noteworthy that will be discussed in separate board that here in Bombay High run of Kutch there is abundance amount of gas and petroleum. What does it show? It shows that this was a land part, this was in the south, this was on the equator, and on equator there was equatorial climate resulting into equatorial vegetation. But when it reached here and due to tectonic process it got submerged, the sediment brought down by the marine wave erosion was deposited over this vegetation, and due to the deposition of that sedimentation it became higher, hence called Bombay High, and the vegetation was overlain with the high by the thick volume of the sediment, hence it is called Bombay High, having rich deposit of gas and petroleum. Here one noteworthy thing is that this Chagos Lakdweep plateau is today submarine, but its basal rocks or structures are of Aravalli and Dharwad system. It also explains that the Aravalli, Archean and Dharwad period rocks or structures are found in the base of this Lakshadweep island. It shows that this Lakshadweep plateau, today submarine, was the integral geological part of this plateau land. Although this Lakshadweep plateau today is mostly made up of coral deposit, because we already have discussed in world geography, and we will in detail discuss why corals are found here. Once there was a question asked by UPSC that discuss the structural difference between Lakshadweep and Andaman Nicobar. So the difference between the two may be explained tectonically well, as we have discussed that structurally this Lakshadweep belongs to Archean and Dharwadian system, but today it is made up largely of coral deposit. While explaining here the Andaman and Nicobar island in linear position, we discuss that these are made up of sedimentary sandstone structure which belong to the structure of Himalayan and its southern trunk Arakan Yoma, and the same structures or rocks are found here. But here another structure is volcanic, found near Baren and Narkondam. Why volcanic activities took place here? Because it is the eastern plate margin of Indian plateau, and today Baren is an active island. Third structure found here in Andaman Nicobar is also coral. Thus, in Andaman Nicobar, three structures: Himalayan sandstone, volcanic and coral, while in Lakshadweep the basal rocks are Archean, Aravalli and Dharwadian, and the surface deposits are coral. Thus, this is about the 90 East ridge, which is along the eastern margin of Indian plate. And one noteworthy thing here is that along this Sumatra and Java there is destructive plate margin. Eastern, it is the northeastern plate margin of Indian plateau. Geophysically, it is also very attractive questions may be asked? Because generally in Java, Sumatra, here in Underman, like Byron, a number of volcanic activities take place. Tectonically, seismologically, volcanologically, this line is very active and prominent because volcanic activities here take place, and when earthquakes take place here, earthquake generated seismic waves or tsunami waves affect this area which hit the eastern coast of India. That's why it should be discussed in detail because questions may be asked in this region. Here the eastern margin of this Indian plate is destructive. Here it is the Myanmar plate or the Indo-China plate. The collision between the two is resulting into here seismic activities. Now there may be a question whether Indian plate is subsiding here below Indo-China plate or Indo-China plate is subsiding below Indian plate. Answer is very simple. This Indo-China plate or Myanmar plate is part of Eurasian plate, which is continental, certainly lighter than this Indian plate. There may be a separate question whether this Indian plate is continental or oceanic. For its answer, you first see the boundary of Indian plate or Indo-Australian plate. Within this boundary, the large tract of water body is here. Hence, it is oceanic plate, that is heavier, and that's why its rate of motion is very high. It is still moving at 4.5 centimeter per year, and this plate is continental plate. Hence, the Indian plate is submerging into this continental plate. Now come to this plate margin passing through Sumatra and Java. Here it is Indian oceanic plate. To its northeast, it is West Pacific oceanic plate. Now, this oceanic plate and this oceanic plate are colliding. There may be a question whether Indian plate is submerging below Pacific or Pacific plate is submerging below Indian. In this context, you take a decision that Indian plate, although is oceanic, even then its some part has continental area lighter than the oceanic. Contrary to it, the West Pacific plate is completely oceanic, denser in structure than this Indian plate. Second point is the western margin of West Pacific plate has a number of trenches which show that the western margin of West Pacific plate is subsiding either below this Eurasian plate or here below this Indo-Australian plate. Thus here there are a number of trenches, but here there is no trench. Thus this belt, Sumatra, Java lineament is tectonically very sensitive and very active. Here one very important point, whether this Australia is independent plate or not. In the beginning we have already discussed that this area surrounding includes Indian and Australian plate, which was in the beginning collectively called Indo-Australian plate. But because the Indian plate is moving eastward at a fast rate, but when Himalayas originated, its speed was decelerated, its northward motion was diverted, and it started northeastward rather northward. With the result, here there was a fracture developed along 90 East Ridge. At that time, Indian plate was separated from Australian plate, hence 90 East Ridge. Why Indian plate and Australian plate got separated? We have already discussed it, that due to deceleration of the speed of Indian plate and its redirection towards northeast. Second very important point of separation is that when the western hard Aravalli collided with Tibetan plate near Dras, its western part was forced from below, raised up, resulting into the drainage of Indian plateau from west to east. When the drainage moved from west to east, the Ganga and Brahmaputra, which previously used to flow westward in the name of Indo-Brahm river that we will discuss in detail, started moving eastward, and voluminous amount of sediment was deposited here. World's largest, deepest, most active geosyncline was developed here. This part was depressed, which we will discuss separately as evidence, and due to the subduction here, the land underwent crack, and this crack called 90 East Ridge, which separates today this Indian plate and this Australian plate. Thus, this Australia was separated from the Indian plate. But it is noteworthy thing, Indian plate or India has plate margin. That's why in India there are chapters studied by students like earthquake, volcano. Contrary to it, this Australia continent or country does not have plate margin, destructive or constructive, close to the coastline. That's why there is no chapter in the geography of Australia like volcano and earthquake. Now let us reach 50 million years ago. Indian and Australian plates reunited at present. Reunited, it means once there was a fracture here, but 50 million years ago this fracture was filled by the joining together of this Indian plate and Australian plate. Means there was no tectonic rift or line, but today at present Indian and Australian plates are again disintegrating. Why disintegrating? Its cause may be the sedimentation in the Bay of Bengal and the rapid rate of subduction of the Bay of Bengal geosyncline. That's why here fissures have developed again, resulting into the barren active volcano. Thus, today geologists and geophysicists say that Indian plate and Australian plate are again disintegrating. Thus, this is the brief geological history of Indian plate, its boundary, and the tectonic activities taking place along this constructive plate margin and along this destructive plate margin. This is the plate tectonic, or say paleoplate tectonic of Indian plate. Although we will discuss in detail the neotectonic of Indian plate, but here to indicate one tectonic future is that here if we draw a line connecting Delhi Haridwar, and Harsil is a village in Uttarakhand, Uttarkashi. If we draw a line and it extends northeastward, reaching to Okhotsk Sea to the east of Asia continent, and it will extend southward, passing through Bhuj, and will connect this Carlsberg Ridge. Here, some tectonic evidences are there. For example, most of the earthquakes today are occurring along this Delhi-Haridwar-Harsil ridge. It is also supposed that when this Indian plate will turn northeastward, move at a rapid rate, certainly a fracture will develop here, a ridge will be formed, and there will be a constructive plate margin in spite of this destructive, and this Carlsberg ridge, that is constructive plate margin, will extend through Delhi-Haridwar-Harsil ridge, and Indian land will got separated from the Suleiman and Kirthar, and from along this line a new ocean will open. But it is not going to happen very soon. It will take sufficient geological time. It is the new tectonics of Indian plate. Thus, if there is question by UPSC on the mechanism of Indian plate, Indo-Australian plate, or Gondawana plate, you will first delimit the Indian or Indo-Australian plate, then give the mechanism in different stages, phases, chronologically, and at the same time you will be giving or describing the evidences in brief. But the evidences will be discussed in detail, because on each and every evidences there may be independent question by UPSC.